The most terrifying thought in astronomy is not the possibility of finding an alien civilization. It is the chilling, existential dread of realizing we may have missed them entirely. Imagine looking up at the night sky, searching for radio signals from distant worlds, only to have a far more devastating revelation. What if they weren't out there, but right here? What if Earth, your home, already hosted a technologically advanced species, and we, humanity, are not the universe's triumphant firstborn, but the lonely, belated inheritors of a cosmic junkyard? This is the unsettling premise that flips our perception of time, life, and destiny. We assume that 4.5 billion years of Earth history has led inevitably to us, the pinnacle of intelligence. But what if the only reason we are here, broadcasting our existence into the void, is because the previous civilization failed? What if we are not the first, but the last? I know what you are thinking. You are picturing grand, crumbling monuments, maybe a colossal, overgrown pyramid, or a submerged city of impossible alloy, waiting to be discovered under the Amazon or the Antarctic ice. That is the antithesis, the common-sense view, rooted in our deep-seated archaeological bias. We assume that a civilization, by its very nature, must leave behind stone, metal, and recognizable structures. But what if the civilization we are searching for vanished not 10,000 years ago, but 10 million years ago, or 50 million? This is where astrophysics meets geology, creating a truly shocking thesis, the Silurian hypothesis. It is a proposal put forth by astrophysicist Adam Frank and climatologist Gavin Schmidt in a 2018 paper. They asked a simple yet profoundly destabilizing question. Could we detect evidence of an industrial civilization that existed on Earth millions of years before us? You see, the geological record is a relentless, unforgiving shredder of evidence. Anything left on the surface, cities, cars, computers, even our greatest works of engineering, would be pulverized, eroded, subducted, and melted back into the mantle over the span of a few million years. The Great Pyramid of Giza is 4,500 years old. That is an astonishing span of human history. But 4,500 years is nothing more than a geological blink, a single infinitesimal fraction of the time that separates us from the age of dinosaurs. If a species achieved global industrialization, harnessing massive energy, building complex infrastructure, and fundamentally changing the planet, and then disappeared, what would they leave behind in the deep time of the rock record? The shocking conclusion is that their legacy would not be a ruined city, but a subtle yet distinct layer of chemical anomalies in the sediments, an esoteric ghost signature visible only to the most meticulous geochemists. This idea utterly demolishes the ingrained human assumption of our own primacy. We look at the fossil record and see simple life, then complex life, then the dinosaurs, and finally ourselves. We place humanity at the apex, the triumphant culmination of planetary evolution. But the Silurian hypothesis forces us to confront the terrifying possibility that this linear narrative is a self-serving delusion. It suggests the peak may have happened long ago, and that we are merely the second act, or perhaps the final, desperate encore. To truly grasp the magnitude of this paradigm shift, we must first look at how humanity has historically viewed its place in the cosmos. Our arrogance is not new, it is a feature of our intellectual evolution. For millennia, the cosmos was a stage built exclusively for us. You can trace this back to the ancient Greeks, to the magnificent yet fundamentally flawed vision of Ptolemy. Imagine yourself standing in Alexandria 2,000 years ago. The cosmos, as you understood it, was a perfect set of nesting spheres, an intricate celestial clockwork. Earth was the motionless center, the divine focal point. The sun, the moon, the planets, and the stars all were forced to revolve around us. This geocentric model wasn't just astronomy. It was a profound statement of theological and philosophical importance. It placed humanity at the physical and moral center of existence, making us the undisputed first and only audience for the cosmic drama. This vision held sway, reinforced by religious authority, for well over 1,500 years. It was a comfortable, self-affirming narrative that made the universe small, knowable, and ultimately human-centric. Then came the seismic intellectual shift of the Renaissance. Copernicus dared to suggest that the Sun, not the Earth, was the center of the solar system, the heliocentric model. This was the first great dethroning of humanity. Suddenly, we were not the center. We were simply one of several planets orbiting a star. It was a terrifying demotion, but the universe was still relatively small, still contained by a sphere of fixed stars. We were the first inhabitants of this solar system, perhaps, but the real rupture came with figures like Giordano Bruno, who looked at the new, sun-centered cosmos and went a step further. He argued, with fatal conviction, that the stars were simply other suns, each potentially surrounded by its own planets, perhaps infinite in number. Bruno's vision was of infinite worlds, a universe teeming with possibilities, where life was not unique to Earth, but a common natural occurrence. This was the intellectual birth of the search for extraterrestrial intelligence, the first time humanity seriously considered that we might not be the only civilization. Yet, even in this new, vast, and infinite cosmos, a subtle form of human hubris persisted. We simply exchanged the title of the only for the first to achieve this. We looked at our nuclear power, our radio waves, and our space probes, and saw ourselves as the leading edge, the triumphant pioneers of intelligence in our cosmic neighborhood. The modern scientific consensus, until very recently, has essentially been a sophisticated version of this. Life is probably common, but complex, intelligent, industrial civilization is rare, and we are, at the very least, among the first to reach this stage. The Silurian hypothesis is the intellectual sledgehammer that shatters this last bastion of human ego. It suggests that if life is common, and if the timeline of Earth is 4.5 billion years long, a truly unimaginable stretch of deep time, then the odds of us being the very first industrial civilization on this one planet are statistically minuscule. The Earth has had 400 million years of complex, multicellular life. Why should we assume that only the final 200,000 years, the span of Homo sapiens, is when intelligence finally hit the jackpot? This brings us to the core conflict, the true war of ideas that defines modern astrobiology, the Fermi paradox. In 1950, the brilliant physicist Enrico Fermi, during a casual lunch conversation, famously posed the question that now bears his name: where is everybody? The context for this question is a powerful, almost inescapable argument. Our sun is relatively young. There are billions of stars in the Milky Way that are billions of years older. If civilizations are a natural outgrowth of planetary evolution, then statistically, the galaxy should be swarming with them. Given the time available, billions of years, even slow, self-replicating probes could have colonized the entire Milky Way by now. The universe should be loud, bright, and overtly engineered. But it is silent. That silence is the paradox. This silence forces an intellectual confrontation between two opposing camps. On one side, you have the "we are first" model. This school of thought, often associated with the concept of the Great Filter, argues that the silence is proof that the critical evolutionary hurdle, the filter, is behind us. This filter represents an extinction-level bottleneck that is incredibly difficult to pass. Perhaps it was the jump from single-celled life to complex eukaryotic cells. Perhaps it was the emergence of multicellularity, or the development of intelligence itself. If the filter is behind us, we are the statistical anomaly, the lucky ones who slipped through. We are the first, and therefore, the universe is quiet, because everyone else is still stuck in the primordial soup, or never made it out. But then you have the opposing model, the one that the Silurian hypothesis feeds into, the "we are last" model. This model suggests the filter is ahead of us, or perhaps, in the case of Earth, it has already claimed victims. The filter is not a biological hurdle, but an ecological one, tied to the very act of industrialization. The core of this conflict is the nature of a technological civilization. Look at human history. The moment we harness massive, non-renewable energy sources, coal, oil, gas, we begin to change the planet's atmospheric composition, its biodiversity, and its climate. This period of rapid global industrialization is inherently unsustainable. The "we are last" perspective argues that perhaps every civilization reaches this stage, experiences a rapid, planet-altering period, and then collapses, either through self-destruction, nuclear war, engineered plague, or, more subtly, through catastrophic, self-inflicted climate change and resource depletion. The Silurian hypothesis escalates this evidence against the old "we are first" model. It uses the Earth's own history as a weapon. If a civilization on this planet, with this perfect biosphere, could rise, industrialize, and vanish without leaving behind recognizable monuments, then the filter isn't a cosmological event. It's an inevitable planetary feedback loop. It means the filter is the industrial age itself. It suggests that reaching a technological peak is not a triumph, but a planetary fever that inevitably burns itself out, leaving behind only a faint geological scar. The opposing models clash violently over the fate of our own species. Is the silence of the cosmos a sign that we are special and destined to thrive? Or is it a universal warning that the critical stage, the one we are currently in, is the one that kills everyone? The true paradigm shift occurs when we stop looking for ruins and start looking for chemical anomalies. This is the cognitive point of no return presented by Frank and Schmidt. If we want to find the hypothetical Silurians, we must abandon the methods of archaeology, the shovel and the brush, and adopt the methods of deep-time geology and paleoclimatology. The evidence of a civilization is not a statue, it is a signature of unsustainable energy use. Think about the sheer amount of material we move, process, and excrete into the environment. We are currently creating what future geologists will call the Anthropocene layer, a distinct, globally recognizable stratum of human industrial activity. What would this layer look like 50 million years from now, after tectonic plates have shifted, mountains have risen, and oceans have boiled away and returned? The key is that the layer would be fundamentally non-biological in its composition. First, look for plastics and synthetic polymers. These materials, the defining hallmark of our current age, are practically immortal on human timescales. While they eventually break down, their chemical components, the long chain molecules, would leave behind a detectable, if fragmented, residue in the sediment record. Second, search for fossil fuel combustion byproducts. The burning of coal and oil releases vast quantities of carbon into the atmosphere, which then gets absorbed and eventually sequestered in the rock record. A sudden, sharp spike of carbon-12, the lighter isotope favored by ancient fossil fuels, would be a massive red flag. This spike would be a short, intense geological burst, a few 100,000 years at most, sandwiched between millions of years of natural, slow carbon cycling. Third, look for radioisotopes and rare earth elements. Our nuclear power plants and weapons leave behind unnatural isotopes, such as plutonium-239. While these decay, the process is measurable. Furthermore, the massive global mining of rare earth elements, vital for our electronics and batteries, would create an unprecedented, globally distributed layer of these metals, far exceeding their natural concentrations. This is the great metaphorical shift, the breaking of the old paradigm. We are no longer limited to searching for a civilization that lasted long enough to achieve interstellar travel. We are looking for any civilization that lasted long enough to achieve industrial self-destruction. The rupture is the realization that the most durable legacy of an advanced civilization is not its technology, but its waste. This shift recontextualizes our entire search for life in the universe. We have been looking for the cosmic equivalent of the Roman Empire, a civilization that left behind magnificent, persistent ruins. The Silurian hypothesis forces us to look instead for the cosmic equivalent of a massive ancient oil spill, a telltale chemical stain that marks a planetary fever pitch. It transforms our understanding of ruins. A ruin is no longer a broken wall. A ruin is an anomalous spike in the geochemical data of a 50-million-year-old rock layer. And the most chilling part of this recontextualization is that if such a signature exists on Earth, it means the Great Filter is not a cosmic lottery, but a predictable, self-imposed limit. It means that any species that develops the capacity for industrial self-consumption is effectively signing its own geological death warrant. The consequences of accepting the Silurian hypothesis, even as a powerful therapeutic thought experiment, are profound, creating a staggering cascade effect across multiple scientific disciplines. For astrobiology, the legacy is immediate and disruptive. If the Earth, our own planet, can host an industrial civilization that vanishes without a trace in the archaeological record, what hope do we have of finding a similar, short-lived civilization on a distant exoplanet, maybe orbiting Kepler 186f? The search for extraterrestrial intelligence, or SETI, has traditionally focused on radio signals, the so-called technosignatures. But radio waves fade, and a civilization's broadcast window might only last a few thousand years, an impossibly short time in the vastness of the galaxy. The Silurian hypothesis suggests a new, more durable technosignature, the exo-Silurian signature. Instead of listening for a broadcast, we should be looking at the atmospheres of exoplanets for transient, anomalous spikes in non-equilibrium gases. We should be searching for the atmospheric equivalent of a planetary hangover, a sudden, intense release of methane or chlorofluorocarbons, followed by a long, slow return to natural equilibrium. The search shifts from looking for the long-lived civilizations, the ones that survived their industrial phase, to looking for the ghosts of the ones that didn't. This is the new prolepse for planetary research, hunting for the fossilized waste products of dead civilizations across the galaxy. Furthermore, this hypothesis forces us to reevaluate our own planet's history. We must now apply the rigorous geochemical methods of the Silurian search to Earth itself. Could the Permian-Triassic extinction event, the Great Dying that occurred 252 million years ago, or another mass extinction, have been initiated or exacerbated by a previous non-human industrial species? I know what you are thinking. That sounds like science fiction, but the data must be allowed to speak for itself. If we find an anomalous, sudden spike of non-biological carbon in the deep rock record that precedes an extinction event, we are intellectually obligated to consider the possibility. The idea of a pre-human civilization is no longer a fringe theory. it becomes a valid, if highly unlikely, null hypothesis to test against the geological data. This intellectual polyphony, this dialogue between the geologists and the astrophysicists, is the true power of the idea. It forces us to confront our own fragility. If the great filter is indeed the industrial phase, then we are currently living in the crosshairs. We are not the first species to face the challenge of planetary-scale resource consumption and climate alteration. We are simply the latest. The legacy of the Silurian hypothesis is a chilling mirror. It suggests that the history of the universe may not be a long, slow march toward intelligence and galactic unity, but a repetitive, cyclical pattern. Life emerges, intelligence develops, industrialization occurs, and the planet attempts to purge the fever. The ultimate enigma, the terrifying question that remains, is this: if we are not the first, but the last, what exactly does that make us? Are we the lucky inheritors who might learn from the faint geological scar of our predecessors? Or are we simply the final, doomed iteration of a planetary cycle that is already underway? Look closer at this world, at the carbon we burn and the waste we generate. We are currently writing our own geological obituary, a faint chemical signature that some future non-human species might one day uncover. The greatest mystery in the cosmos might not be what lies out there, but what has already been destroyed right here beneath our feet. And that, my friends, is a terrifying thought to take to bed.